How do you handle the late arriving records in Spark streaming?
To handle late arriving records in the Spark structure streaming, uh, we can use the watermarking. So watermarking is a key feature in the Spark structured streaming that allows you to specify a threshold for how long or how late data can arrive before it considered as like too late to be processed. So we can define some window length. It comes like threshold definition. We have a method like with watermark method. So using that, we can specify the maximum delay that you are willing to accept the late arriving records. So we can track like event track changes. Like we need we can define this watermarking on some event time column. So event time column, we can specify what is the maximum allowed time that it can process. Like event time, it will be like 1 hour. So it will wait for, it will move all the records which are older than 1 hour. It will still maintain its state. So if it is older than 1 hour, it will truncate or it will delete that data. So this how it will maintain the late arriving records in the Spark streaming.
How will you upgrade the Spark version in Spark streaming jobs?
Okay, upgrading the Spark version in Spark streaming jobs, it requires a careful planning and execution to ensure that a smooth transition without any data loss and significant downtime. So we need to follow different steps. The first step is like we need to review the migration guides. Like before upgrading, we need to understand what are the new features that get added in the Spark new version, and what are the features that it can support as a backward compatibility, and what are the things that it is not supported. So according to that, we need to prepare any code changes, any upgradation changes, any connector changes that you have to taken care. And we need to test in a staging environment. So before we are upgrading it in the cluster in the production, first we'll try to test it in the product in the pre-prod environment or QA environment to see the stability, performance, and reading, and the data logic and everything, like unit testing, integrated testing, and all those things will done it out here. And the next one is the prepare for checkpointing. Like usually if we can upgrade the Spark version, so because of this compatibility issues, we cannot reuse the existing checkpointing files to use run the new Spark version. So to avoid that one, we need to take the exact offset information and other other state kind of an information from the Spark streaming job, and that will be create a different directory, and we should ensure that there is no data loss should happen when migrating. So we need to clear the checkpointing directory by taking the backup, and deploy a new application version. Like along with the parallel, along with running the old Spark version, we need to relaunch a new job with the new Spark version, and then both jobs should read the same length of data and same number of records and same logic, and it writes the data to the disk. And we need to compare the performance difference between the two different versions, and we see is there any things that we need to take in care. So if you believe that the upgrade version is working as expected, and everything is good in terms of the stability, performance, and other areas, and then we can decommission the older instance and keep running the newer version. And post upgradation, we need to check the data validation, verify all the expected data has been processing correctly, or there is any discrepancies are there, and we need to review the performance as well. So by following this step by step process, we can upgrade the Spark version without downtime, or with less downtime.
How do you design a Spark streaming jobs? What things will you check?
So designing a Spark streaming job, we need to check, like we need to understand the use case. Like we need to identify the requirements, and we need to determine the latency and throughput requirements, and we need to choose the right trigger interval, whether it is a batch kind of interval, or one time interval, or it's like continuous interval. And we need to understand the back pressure and back pressure related configuration, and we need to understand what are the data source configuration, like how what is the each micro batch job that we need to process, like how many record or how much data that we need to process, and optimize the input rate. And we need to identify the partition strategies, and we need to implement the checkpointings and state management also. We should taken care, and also output sync configurations, like how we are writing data to the target. We need to handle the error handling and monitoring steps, and end-to-end testing and stability testing just to check. And before moving into the production, we need to check the resource allocation configuration based settings, like executed memory, driver parallelism checks, and also data retention policies, log retention policies, and fault tolerance mechanisms. And we need to maintain the proper documentations, and all those things we need to take in care.
Suppose Kafka Producer is producing high velocity than Spark processing. How can you fix this in real time?
So to address high velocity data production from Kafka compared to Spark streaming, so in this case we need to increase the Spark parallelism, like Spark performance, and increase the parallelism by adjusting the Kafka partitions, and scale up the executors to match the velocity of the producer side to process all the data. And also we need to optimize the batch interval. Optimizing the batch interval is like increasing the batch duration, or increasing the batch duration or decreasing the batch duration as per the business use case. And also to handle the back pressure, like we need to take only certain records, fixed number of records from the source system, and to process the data and to reiterate the data. Or if it is like a high velocity is like some time, like maybe 1 hour or 2 hour, then in that case better you can stop, and better we can run a backfill job which can able to process all the data at once to the target system, and then we can keep rerunning the same job. If the higher velocity is like a permanent one and a permanent kind of one, in that case better we can increase our cluster resources to handle the high speeds, processing the high speeds of the data, hit the high throughput and high processing speed. So depends on the use case, and depends on the scenario. We need to choose the best alternative approach or architectures to meet this kind of use cases.
How a Kafka message will get stored internally.
Kafka will actually store the data in the form of serialized format of binary less of key value format. Like usually it will store the data in a 5 different fields. One is like key, value, timestamp, and topic, partition, and offset. So it will store all this information in the below format, each record. And actually the topics will be divided into the multiple partitions, and each partition will be divided into the segment. So the segments will be created, like the segments will be created, it is a kind of a file. So all the records will get appended to that segment until it reaches the log segment byte limit. So once it reaches the limit, it will create a new file, and then it will add the records to that new file. So the name of this file will be like starting offset position dot log file. So this is how this log segment file will be created. And inside to that, it will also create the index files, like each segment has accompanied with the dot index file that actually maps the offset to their physical location in the .log file. So the storage format, it will actually store it into the serialized format. So once we can serialize, so we can use either Avro or JSON format to deserialize the messages and parse it, and to extract the messages from the Kafka.
What are different output modes available in Spark streaming?
Spark structured streaming has mostly 3 output modes. One is like append, complete, and update mode. Append mode is like only new rows since the last trigger are written, it will be given that as an output. And the complete mode, all rows of the result table are returned to every time there is an update. And in update mode, only the updatable records are sent it to the sync from the last trigger. So append mode will be suitable for logging new events or new records, and most of the cases will use the append mode. And the complete mode is for the streaming aggregations where full state visibility is required. And update mode is useful for observing the changes in aggregated data without a full output.
Can we read the Kafka from multiple topics and from partitions and multiple offsets?
Yes, we can read the Kafka from multiple topics. Like when you are configuring the Spark streaming job, right? So we can define the bootstrap servers or multiple servers, and can subscribe to one topic, or we can give the multiple topics, the comma separated values, so that we can read from the multiple topics. And also when you are subscribing to the pattern, right? So subscribe pattern is available, where using the subscribe pattern, like with some regular expression pattern, we can subscribe for the all the topics and we can read. And also we have other flexibility where we can submit JSON format, like what is a topic and what is a partition and what are all the different set of offsets that we need to return. Like if you pass in a JSON format, it will read only the relevant partitions from the Kafka. So yes, this supported, and this facility was available in the Kafka and Spark streaming.